I'm Anil Kumar. Welcome to my series on functions. We'll discuss inverse functions in this video. We'll begin with basic concepts, look into domain range, and also take up examples to find inverse of functions. Now, let's begin with functions itself. Let's say this is a box in which we throw in some inputs. So let this be the input. The function basically is a set of operations performed on this input, and that gives you an output, right? So in general, you could say that there are inputs. Let me write this as in. We get them as some output after some operations are done by the function. Now, the idea of inverse function is basically to reverse operation. I see it more as reversing the operation, right? So it becomes easier to explain and to understand the concept. So the idea is that if I throw in some inputs and get some output, then on returning these output as inputs, what do we get? We should get what went in, right? So that is the reverse operation. So this operation of performing the reverse thing, that is getting the input from the output, is termed as inverse function. We normally have a symbol like this, f, that minus 1 on the top. So that is the symbol for inverse function. Now let me take an example to illustrate the whole thing. Let's say we have set of inputs here and some set of outputs. Let the numbers be, for example, 0, 3, 1, let's make these arrows, 5, 2, 7, 3, 9. So this is a mapping diagram, as you know, where 0, 1, 2, 3 are the inputs and the corresponding outputs are 3, 5, 7, and 9. We'll call this as our function, right? So let's call this as a function f. Now, what is inverse of this function? The inverse of this function will be that if I input 3, then I should get 0 as the output, right? So the inverse of this function will be to take 3 as the input and give out 0, right? So that will be called inverse operation. So reversing this operation makes it inverse function. So the function which reverses this operation will be treated as inverse of the function. So I hope you get an idea, right? So if I input 5, I should get 1 as an output. If I input 7, I should get 2 as the output. And if I input 9, then I should get 3. So that reversal is what we are looking into, correct? So one way, as you have seen here, if you have a mapping diagram, then you can just reverse the operation and get inverse function, right? So that is how you could get inverse function. Now from this simple illustration, we actually get many things. That is to say that we have a relation between domain and range. So in case we are considering a function f, for example, and its inverse, which is written as f to the power of like this, it is not reciprocal. F, when we write minus 1, it is read as inverse. So we may write f of x as the function. In that case, inverse of this function will be written as f inverse x, right? So this has to be read as f inverse x. So that is inverse of the function f of x. You read as f inverse of x, right? That is how it has to be read. Okay. So what you notice here is that the domain of the function was, in our case, the mapping diagram which we have taken, 0, 1, 2, 3, right? And the range was 3, 5, 7, 9. For the inverse function, they switch. Domain becomes the range and range becomes the domain. As you can see here, the domain of the inverse function will be 3, 5, 7, 9. And the range will be 0, 1, 2, and 3. So for an inverse function, domain and range switches. Right? Now, we could also see these functions in the form of equations. Let me write an equation for our function. As you can see here, 0 is related with 3, 1 with 5. It is going up by 2 for each step in input. So we could say y equals to 2 times x plus 3. So if I substitute 0 for x, I get 2 times 0 plus 3 as 3. 2 times 1 is 2. 2 plus 3 is 5. So I get this as an equation of my function f. Now, meaning of this equation is times 2 and add 3. That is what it means, right? So if you look into the function, it really means to any input. If input is there, then you times it 2 times and then add 3. So what is going to be the inverse or reverse operation? Reverse operation will be subtract 3 and divide by 2, right? So subtract 3 divide by 2 becomes the reverse operation. So we could actually write inverse of this function as x minus 3 divided by 2. Do you see that? Or that is the function notation, or we can write this as y equals to x minus 3 divided by 2. So what we have done is we actually reversed the operation literally and got some equation. Let us check. If I substitute 3 for x, 3 minus 3 is 0, we get 0. If I substitute 5, 5 minus 3 is 2, 2 divided by 2 is 1, 7 minus 3 is 4, 4 divided by 2 is 2, 9 minus 3 is 6, divided by 2 is 3. So that works. So what we have done here is we have shown you that the basic concept of inverse function is to find a function which can return the input from the output, right? So it is reversing the operation, right? So the idea is to find a function that could reverse the operation. Okay, so that is the basic idea. So I hope the concept is clear. We have also seen that the domain of a function becomes the range, and range of the function becomes the domain of the inverse function. Now we'll take up some examples and understand this concept in more details. So let me just summarize what we learned. First thing which we learned is inverse is like reverse operation. Second thing which we also learned is to swap domain and range. That is, when we are considering, let us say, a function f of x and its inverse function, right? Then we basically swap domain and range. Now, we'll take a few examples and then see what functions could be actually written as inverse function, right? So let's take first example with coordinate points. So we have these kind of examples. We'll take coordinate points. Let's say we have a function which is written as let's say 0, 2, minus 1, 3, no particular order. I'm just writing some random values, okay? And let's say 4, 4. If that is my function, in that case, inverse of this function is going to be what? The inverse of this function, which I'm writing with negative 1 as an exponent, a inverse of this function will be just swap x and y. So instead of 0, 2, it becomes 2, 0. That is to say that for 0, 2, input was 0, output was 2. Now if I reverse the operation, if I take 2 as the input, then my machine should give me 0 as the output. That machine will be called inverse function, right? So that becomes 3 minus 1, and 2, 5 will flip 5, 2. 4, 4 will remain as 4, 4. So that will be invariant point. So whenever we have coordinates, they will swap kind of like this, right? Now let's take another example of coordinates. Now let's take function b. This function is a function but with a difference. Let me show you how. Let's say the values are 0, 1, 2, also 1. Now this is a function. Since there are different x values, they may correspond to the same y value, right? Let's say 3, 2 and 4, 5. Now if I have to write inverse of this function, I could write like this. So we'll again swap the values. We'll write this as 1, 0, 1, 2, 2, 3, and 5, 4. However, you will notice that this is not a function, right? So where we notice that this is not a function. Reason being that the function b is not one-to-one function. Here it is many have been related to 1. So in this case it is not a function since b is not one-to-one function. So what you notice here is that you can find inverse of any function, but that may not be a function, right? So important thing to note is that inverse is a function or we can say inverse function is only for one-to-one functions. If it is one-to-many, then inverse will not be a function, right? So that is what we're trying to say here. Let me show this in the form of a graph. So I'll take another example here, which is extremely good example. Let's take a parabola. Now the function here is x squared. So we could write this as y equals to x squared. Now to find the inverse, I'll have to reverse the operation, right? So the inverse of this will be, so what you can do is you can swap x and y and then calculate, but easier way could also be making a diagram like this. So 0, 0 will land up with 0, 0. So that will be the same point. Okay. Let's take some values. I'll get to the equation later. Let's take some values. Okay. So for the x square function, coordinates could be -2. Square of -2 is 4. -1 square is 1. 0, 0, right? And then we have 1, 1 and 2, 4, for example. There could be many other points, but these are critical points which we are taking. On the other hand, the inverse of this function, which I'm writing as y inverse, will really be, swap these points, 4 minus 2, that will be 1 minus 1, 0, 0, 1, 1, and 4, 2. Now if I plot these points, 4 minus 2, that means the x value being 4 and -2 will be somewhere here, right? So let's say this is my first point. Then we have 1 minus 1. Let's say 1 minus 1 is somewhere here. Okay. And then we have 0, 0, which is right there. 1, 1. So 1, 1 will be, let's say, this point. And we have 4, 2, which is on 4 we have this 2, right? So what you notice here is that the inverse of the function will be kind of like this. So that becomes the inverse of your parabola. You clearly see that this is not a function since it fails vertical line test. Right? Not a function. Since we see that, these values 4 and 4, they're corresponding to 2 and minus 2. Right? They are corresponding to 2 and minus 2. So it fails vertical line test. Now the idea is, how do we know that this will not result into inverse as a function? Is with horizontal line test. So what we have here is, if for the function, if I draw a horizontal line, in this case it intersects at 2 points. So we have this horizontal line test. So if the function f of x graph intersects horizontal line at more than 2 points, then inverse is not a function, right? Then inverse will not be a function. So that is the horizontal line test, which is extremely important to understand. So I hope that concept is clear here, right? So you could draw a horizontal line. If it intersects to the graph of the function at more than 1 point, then you cannot have inverse as a function. But at times what we can do is we can actually have some restrictions on the domain of the function, so that while we could only consider one side of this parabola. For example, in this case, the restriction could be x greater than or equal to 0. So that restriction will enable us to make inverse as a function. Do you understand? So this is what we'll now discuss. So I hope till now the concept of finding inverse using points is very clear, and also how we did it using a parabola. And we saw that a function may not have inverse as a function. You could find inverse, but inverse may just be a relation, not a function, right? We could do horizontal line test to check whether the inverse will be a function or not. One more thing which you will notice here is that we are actually swapping the points. It really means that all the points could be graphed by reflecting points on a line y equals to x. We'll explore this in more details now. Now I'll take a few examples to show you how we can find inverse algebraically. We have already found inverse by switching the points or by changing the arrow in a mapping diagram. So let's take some equation of a line. Let it be y equals to 2x, let's say plus 6. Now, to find inverse, what should we do? Well, we have learned that we have to swap points, right? So, swap x, y values, right? In the equation, we can actually swap x and y. So the first step will be to swap x and y. Instead of writing y equals to 2x plus 6, we'll write x equals to 2y plus 6. And then we need to find what this y is, and that will be treated as the inverse of the function. So we could do it by isolating y, right? So then the next step is isolate y. So we'll take away 6, becomes x minus 6 equals to 2y, and dividing by 2, we get what, dividing by 2, we get what y is. So we could write y as equal to half of x minus 3, right? Now this y is called the inverse function since it can do the reverse operation. So we write this as f to the power of minus 1 x. So inverse of the function is equal to half x minus 3. So that is the way of algebraically finding the inverse, right? If we see that on a graph, then we will notice that it is these two functions are actually reflections on the line y equals to x. So let us make an approximate sketch. Y equals to 2x plus 6 means that the line has got, let's say this is 2 for us, 4, 6, 8. So from 2, the line is rising up. Let's say this is, okay. So let me just make a graph which is kind of like this. Let's say this, right? So I'm just making approximate sketch. So the graph will be y equals to 2x plus 6 as shown here, and its inverse, which is minus 3.5. You will notice that minus 3 is right there. It will be a line which goes in this fashion. So when you graph it on a proper graph paper, this is how you will see the inverse of this particular function. So what you will notice is that these two lines are reflection on the line y equals to x. The point where both x and y values are same will be the invariant point. So that is the invariant point, correct? So that is how you can actually graph and see. So let me take another example to illustrate this particular algorithm. So let's take y equals to square root of, let's say, x minus 1. Now in this particular function, we have restricted domain and range. I could actually sketch this function here as y equals to x minus 1 means a square root function shifted 1 unit to the right. Correct? That's the kind of function we have. To find the inverse, we'll swap x and y. That's the first step. So we can write this as x equals to square root of y minus 1. And then we are going to square it. So we get square of x equals to y minus 1. And then we can bring 1 this side. So we get x squared plus 1 as y. Now this part is kind of tricky. What you notice here is that y equals to square root of x minus 1 has a restriction. And the restriction is that x should be, the restriction is that x should be greater than or equal to 1, right? So that is the domain. And for this domain, the range is y is greater than or equal to 0, as you can see, right? So when you find the inverse, which is written here as y equals to x squared plus 1, or f inverse of x as equal to x squared plus 1, we have to swap this domain and range to get the real answer. So x becomes greater than or equal to 0, and the y value becomes greater than or equal to 1. So that really becomes the inverse of the given function. Do you understand? Right? So in this function, if I plot some points, let me do that and extend this idea. So we have this function square root of x minus 1. My values are greater than or equal to 1. So for 1 I get 0, right? For 2 I get 1, right? If I write, let's say 4, let's say 5, then 5 minus 1 is 4 and we get 2. For the inverse function, these values are going to change to 0, 1, 1, 2, and 2, 5, right? So on. This is for the inverse function. Let me write like this. So at 0, I'm getting a value which is 1, kind of like this. At 1, I'm getting a value which is 2. So what you will find here is that the graph of the inverse function actually is a parabola which is only this side of the graph, where x is greater than or equal to 0, and it could be graphed by taking reflection on the line y equals to x. Do you see that? So here we have inverse function. This is square root of x minus 1, and that is x squared plus 1. However, x is greater than or equal to 0. So that is half of the parabola, and that is a function. You can see that, right? So what you learn here is that you can find inverse with equation following these two steps, right? So steps to find inverse of a function is, step number 1 is swap x, y, and step number 2 is isolate y. Step number 3 is also swap domain and range, as we saw here. If you don't do that, you will land up with wrong answer. So these 3 are critical steps to find inverse of any function, as you can see, right? Now based on this, I'll give you some links on finding inverse of a function and some multiple choice question to practice. I hope the basic concept is clear. Now let me summarize few concepts which you have learned in this video. One is we are trying to find inverse of a function which is normally written as f inverse x, right? So what we have learned here is that if the value of a function at a is b, in that case inverse means that value of b is equal to a. That is what it means, right? So if f of a is b, then f inverse of b is a. So basically it is a reverse operation. As you can see, a and b swaps. So for the functions, we have also learned that domain of f of x becomes range of f inverse x, and range of f of x becomes domain of f inverse x. Clear? So all these points I hope are absolutely clear. Now let us consider a few more. We have also learned that inverse is a function only for one-to-one relations, right? So what I'm trying to say here is that we saw that in case of a parabola, which could be sketched as shown here, this parabola fails horizontal line test, and therefore the inverse of this function, which is plus minus square root x, fails vertical line test. Do you see that? So in this example, if the function f of x is x squared, then inverse will be plus minus square root of x, which is not a function. Reason is that the function is not one-to-one, right? So many are related to one value in this case. So what we also learned here in this connection is that horizontal line test. So horizontal line test tells you which functions will result into inverse as a function, right? Is that clear? Now we also learn steps to find equation of inverse function. We'll take one example to conclude. Let's say y equals to 2 times x minus 3 whole square plus 4, right? Now steps are that first we swap x and y. So first step is swap x, y values. So if you do that, you get x equals to 2 times y minus 3 whole square plus 4. The second step is to isolate y. So to isolate y, we'll first take away 4. So we get x minus 4 equals to 2, y minus 3 whole square. Then we'll divide by 2. We get x minus 4 divided by 2 is y minus 3 whole square. Now we'll square root. So whenever you square root, you have to write plus and minus. You get x minus y over 2 equals to y minus 3. And now you can write what y is. So I'm writing in this side. So y equals to, taking 3 on this side, we get 3 plus minus square root of x minus 4 divided by 2. Now you see plus minus, that means inverse is not a function, right? If inverse is not a function, we don't write f inverse x, but we just write f inverse. Do you understand? And that is equals to 3 plus minus square root of x minus 4 over 2. Now I'll take up more videos to show you that how we can restrict the domain and get inverse as a function, right? So the idea is to restrict domain of f of x. So in this case, we could actually do it. We could restrict it on one side of the vertex. So I could do if x is greater than or equal to 3. In that case, we could have got the inverse as a function, which we may write like this: 3 plus square root of x minus 4 over 2. So we are saying if x is greater than 3 for the function, right? So if x is greater than 3, y will be greater than or equal to 4. In this case, it changes. So in this case, x becomes greater than or equal to 4 and y becomes greater than or equal to 3, right? So you see that it swaps. So domain and range swaps. I hope that helps you to understand how to restrict at times the domain of the function which fails horizontal line test and get inverse as a function. Now in this particular example, we restricted the domain of our parabola to right side of 3, x greater than or equal to 3. Now for that function, range is greater than y. In the inverse, what we got was that the domain and range has swapped. Domain now becomes greater than or equal to 4 and range becomes greater than or equal to 3. Now for every function which fails horizontal line test, we could restrict the domain, sometimes the range, so that we can ensure that the inverse is a function, right? So that's an additional thing which we learned here. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.